A rumor is spreading through the halls of the local college. The math professor has modeled the number of people that know the rumor with the function p of t is 1,250 divided by 1 plus 124 e to the negative 0.95 t, where t is the time in days since the rumor was started. We want to just use this model to answer a few questions. So how many people started the rumor? Well, let's make an assumption here that the rumor was started on day 0. And so let's consider that to be day 0. That's when it started the rumor. So then let's evaluate p of 0. That would be the number of people who knew the rumor on day 0. They would be the ones who started it. All right, so p of 0 then would be 1,250 over 1 plus 124 e to the negative 0.95 times 0. All right, well, let's see. Negative 0.95 times 0 is 0. E to the 0 power is 1. So then that would be 1,250 over 1 plus 124 times 1. Well, 124 times 1 is 124. 124 plus 1 is 125. So we have 1,250 over 125, which is 10. All right, so using this model, it seems like, 10 people started the rumor. How long does it take for 600 people to know the rumor? All right, well, we have our function, and we want to see how long it will take for that function to achieve the value 600. We want to find the value of t. So let's set the function equal to 600. So I have 1,250 over 1 plus 124 e to the negative 0.95 t equals 600. All right, so to solve this, what I will do is I will get rid of that fraction. I'll multiply through by the denominator, 1 plus 124 e to the power. So then 1,250 would equal 600 times 1 plus 124 e to the negative 0.95 t. Let's apply the distributive property. 1,250 would then equal 600 plus, I can't do that arithmetic in my head, 600 times 124 is 74,400 e to the power. All right, now we've got to solve this. Now this is an exponential equation. We hopefully know how to solve that. Let me subtract the 600 from both sides. All right, so then 650 is 74,400 e to the negative 0.95 t, and divide through by the 74,400. And I'm just going to flip the side so that way t is on the left. So now e to the negative 0.95 t, and I'm just going to leave that as 650 over 74,400. Now to solve for t, let's apply the natural log. So then negative 0.95 t is the natural log of that quantity, 650 over 74,400. And finally divide through by the negative 0.95. So then t would be the natural log of 650 over 74,400 and divide that by negative 0.95. And that one's way too complicated for me to do in my head. Let's calculate that. So on my calculator, I would type in the 650, divide that by the 74,400, enter that, natural log of that, and then divide that by negative 0.95. And it's 4.989. That's, we're going to say t is about 5 days. So it's going to take about 5 days for 600 people to know the rumor. All right, now, the last part, C, asks us, after many days, how many people will know the rumor? It doesn't say how many, it just says many days. So what's the long-term, what's the end behavior of this function? That's really what it's asking. What's the end behavior? And so using arrow notation, we can sort of think of this as saying, as t approaches infinity, p of t approaches, and we need to figure out, what does it approach? All right, so let's think about that some more. So I copied the function down again. There's our function. All right, so what happens as t approaches infinity? Well, we have this e to a negative power in the denominator. And if you remember something about the exponential function with base e to the kt looks like one of two graphs. E to the kt is either an increasing function, here k is positive, or e to the kt is a decreasing function if k is negative. And so here we have this e to the negative 0.95t. K is negative. It's a decreasing function. And what I see here is that as t approaches infinity, right, as t, arrow infinity, e to the kt is approaching 0 for k negative. All right, so what that's telling me is, here, this e to the negative power, as t is approaching infinity, this e to the power is going to go to 0. So, as t is approaching infinity, this expression becomes 1,250 over 1 plus 124 times 0. Well, 124 times 0 is 0. So that's 1,250 over 1, which would be 1,250. So as t approaches infinity, p of t approaches 1,250. So this model tells us, after many days, 1,250 people will know the rumor. Now this function that I wrote down is called a logistic function, and it's related, it has an exponential term in it, but it's the one way we can think of a logistic function is starts off sort of exponential and then levels off. Sometimes we can think of this as exponential growth, but with limited resources. And I graphed this function on Desmos. And here's the graph. And my window settings are roughly, from 0 to 20 on the x-axis, and roughly 0 to 1300 on the y-axis. And we see that the curve starts looking like an exponential function. And then we have, and you'll learn about this in calculus, we have what's called an inflection point, where the concavity of the curve changes, and then the curve, the rate of change is different, and then we get a what we sometimes call the carrying capacity of the function. In this case, that's the 1,250. And we see a horizontal asymptote at 1,250. All right, so this is, again, a logistic function, and we can often think of this as an initial, a very simplified initial model for even some things like the spread of disease. But there are much better models that are being studied for that. So anyways, this is an example of a logistic model and some of the things we can learn just by analyzing it.